Our modern society is totally dependent on geo-resources. Human communities need constantly both energy and non-energy minerals to exist. The latter ones are essential for manufacturing and supply of renewable green energy. They also provide materials to build homes, schools, hospitals and infrastructures. Despite some financial downturns across the globe over the past 10 years, the demand for raw materials such as non-energy minerals keeps increasing due to the improving average condition of the world economy and population growth. A continuous supply of minerals will be necessary also in the future to boost both developed and developing countries. Minerals are at the base also of the digital revolution in which we are living. At the present time, minerals are essential, and so mining is vital for our civilization as it was in the past. Mining generated wealth has the potential to improve the economy, infrastructure, and the quality of life, and brings opportunities for economic growth and diversification. Mining generates revenue for governments through royalties and tax incomes. It also brings skilled employment, technology transfer, and training for people, together with further jobs through the multiplier effect. So mining can bring substantial improvements in physical, social, legal, and financial infrastructures. But if not properly managed, economic growth and development can come at a cost to the environment and to the social equilibria of local communities, with the possibility of irreversible negative consequences. Past and present over-exploitation of resources, rampant consumerism in post-industrial societies, and massive inequalities in wealth, health, and access to resources have undermined the social reputation of mining. Advances in technology and changes in management techniques are now making many negative impacts avoidable. And the adoption of new policy and communication strategies based on ethical approaches to manage environmental and societal issues are changing the public attitudes towards mining. Increasingly, mining companies are making efforts to reduce the social and environmental impact of mining and to minimize the footprint of their activities throughout the mining cycle, including restoration of land and ecosystems after mining. Initiatives like Mining with Principles of the International Council of Mining and Metals represent tangible efforts to create a new paradigm for activities that are unfortunately globally perceived more for their negative consequences on the human health and ecosystems rather than for their opportunities to create wealth and development for society. Two fundamental concepts like sustainable development and geoethics can help to change the cultural and operative paradigm in mining. In 1987, the Brundtland Commission of the United Nations defined the sustainable development as the development that meets the needs of the present without compromising the ability of future generations to meet their own needs. This definition connects the concept of sustainability with the geo-resources. In addition, it claims that sustainability is a concept deeply linked to human needs. Sustainability is a value insufficiently considered in our current development models, although it is the way to guarantee the longevity of the system supporting human life. Pursuing sustainability requires responsible human action, which is suitable for this value. Applying sustainability to geo-resource management raises the need to minimize and optimize the production and use of energy and minerals, and to facilitate transition to the use of renewable energies, and informs development of strategies and technologies for doing so, maximizing the positive and minimizing the negative social and environmental impacts of such geo-resource use. However, sustainability also highlights the need to build new models of economic development, recognizing that it is a fundamental human right not to live in poverty, and that a global society that ignores this right cannot be truly sustainable. The concept of sustainable development captures a tension between the need to facilitate the economic and social development of the world's poor and the need to reduce and, where possible, reverse damage to the Earth system. But it also raises the possibility of reconciling these challenges. Development and sustainability should coexist, and we should explore how they can be reconciled, for example, through concepts such as restorative sustainability, that is, ensuring that interventions such as resource extraction do net good rather than net harm. In 2012, the International Association for Promoting Geoethics defined geoethics as the research and reflection on the values that underpin appropriate behaviors and practices wherever human activities interact with the Earth system. Geoethics deals with the ethical, social and cultural implications of geoscience knowledge, education, research, practice and communication, and with the social role and responsibility of geoscientists in conducting their activities. The definition of sustainable development and geoethics contain numerous suggestions for creating a new cultural paradigm that might ensure more responsible human actions towards humankind while respecting Earth dynamics. In this context, geosciences play a fundamental role to understand the nature and distribution of georesources and to define the boundaries of how to live sustainably on the planet. Geoscientists are fully aware that georesources in the Earth system are finite and know that geoethics can help to define appropriate behaviors, practices, activities to assure sustainability to our interaction with ecosystems. Linking sustainability and geoethics to mining activities means to introduce a modern concept in the georesource management, the concept of responsible mining. The document released by the International Association for Promoting Geoethics on this issue clearly expresses that responsible mining demonstrably respects and protects the interests of all stakeholders, human health and environment, and contributes discernibly and fairly to broad economic development of the producing country and to benefit local communities while embracing best international practices and upholding the rule of law. Applying responsible practices in mining activities needs that different stakeholders take into consideration prudent extraction and use of georesources. Responsible mining is based on the respect of the natural environment by minimizing the impacts of mining activities and on the need to increase the awareness and respect of local populations, the adoption of high standards of quality and the improved health and safety conditions in the working environment, as well as the development of innovative technologies and the implementation of eco-friendly and social-friendly best practices. Whatever operative and technical approaches are adopted, however, rigorous application of ethical criteria implies the risk that individuals face insoluble dilemmas. Such challenges, though far from being unique to geosciences, should be studied from a geoethical perspective to assist geoscientists to face them in a professional capacity. The contribution of geoscientists is indispensable on different levels, not least in revealing some hidden contradictions and ambiguities. Often, choices that are widely considered more sustainable or more environmentally friendly than others may not be such, at least in an absolute sense. For example, many technologies and strategies for reducing fossil fuel use will require very significant quantities of mineral resources. These include many metals which have not previously been widely used, as well as bulk metals such as copper. The extraction and processing of these minerals and the complex interlinked global supply chain that stem from them, if not carefully managed, pose significant environmental risks as well as potential social harm in the form of conflict minerals, human rights abuses in the artisanal mining sector, including in relation to child labor, and many other less visible impacts on communities. Such contradictions and ambiguities must be identified and addressed with relevant stakeholders and communities. Geoscientists also have the ethical responsibility to use geoscience knowledge to help frame this problem, inform decision-making, and facilitate effective and sensitive implementation of these decisions. The white paper on responsible mining by the International Association for Promoting Geoethics lists a set of 13 practices and guidelines for developing and implementing mining activities in a responsible way in order to minimize social conflicts and environmental degradation. They include to identify and engage all relevant stakeholders, conduct open, inclusive, and continuing dialogue with local communities throughout the mining cycle to create strong, transparent, trusting, collaborative, and lasting relationships. Engage with communities and stakeholders and identify areas in which there is reasonable alignment of values, implicitly both economic and ethical. Protect the environment and minimize or mitigate any environmental impacts on people and communities, including on the use of resources such as energy, water, and productive soils. Cooperate closely with regional and local stakeholders better to understand biodiversity and conservation issues, increase biodiversity awareness, and thereby improve biodiversity and geo-resource management practices. Acknowledge the possibility that when a project does not meet basic environmental and social criteria for acceptance, building and operating a mine is not the right outcome. Promote energy savings and increase the use of renewable energy sources such as solar panels and wind to reduce carbon dioxide emissions. Manage waste in an efficient and safe way by improving its transportation and tailings management, preventing any environmental contamination and reusing waste where possible. Plan closure and rehabilitation based on environmentally and socially sustainable standard elements and management systems. Conduct tailor-made and fit-to-purpose research to develop technology innovations and advanced methodologies to reduce potential negative environmental impacts. Guarantee access to conflict-free minerals by exploring for potential sources of these minerals outside active conflict zones or replacing conflict minerals. Provide a safe and healthy environment, working environment for all employees and contribute to the health and safety of surrounding communities. Educate students on the importance of effectively managing mineral resources as well as protecting the environment and assuming social responsibility. These 13 points aims to build a system capable of ensuring and promoting responsible extraction of minerals and developing a proper alignment of the corresponding benefits at local, regional, national and global scales. These points clearly underlines that responsible mining does not only require actions and commitments from mining company, but it is likewise dependent on the active and constructive engagement and involvement of all stakeholders, including governments. It is vital to work with local communities and stakeholders to determine where there is reasonable alignment of economic, social, cultural, and ethical values, to work to reconcile these, to seek opportunities for collaborative action to maximize social and environmental benefit in order to resolve conflicting interests. Dialogue between stakeholders is the operative and effective way to assure the common good. In responsible mining, dialogue is the key.